Alright guys, welcome back to question 4. Now let's have a look at this one. My name is Gaston Mapala, right here at Maths with Gaston, this channel solely focus on pure maths and how you would solve questions and lessons and dealing with the different questions and the knowledge, the basics of being able to answer these questions and to ensure that you get that level 7. Now let's have a look at this question. In the diagram, M is the center of the circle having this equation. Okay, let's see. It means now this is our center here would have to be 3:0. This is our center, and therefore from the center going there is the radius. So radius here it's 5 because here it's a 25. So even here up until this point our radius will therefore be 5. Okay, then they said E is given at -1, -1 and 3, and T is a point on the circle. So T, there it is, it's just a point. E, here it is sitting right here, and then they said EC is a tangent, so this line is a tangent, therefore makes this angle to be 90 degrees. And then it cuts at the x-axis at point D. There it is here at point D, so it means here the coordinates of D, it means y is 0 because it's in the x-axis. And then they said ED, so this here, the distance here is 1/5/4. Okay, and then MT is produced to meet at point C. Okay, there it is. Great stuff. So let's go 4.1. 4.1, write down the size of E, which is this angle here. They've already told that it's a tangent, so therefore it's perpendicular. They just said you must write it, so it's going to be just 90 degrees. Okay, and then they said 4.2. 4.2 said determine the equation of a tangent EC in this format. All right, the equation of this line here, which is a tangent line EC. So this is the equation of this line. So let's come here. 4.2. 4.2, if it's a tangent, therefore we know that if it's the gradient of CE, when you multiply it with the gradient of EM, is going to give us -1. So here we don't have a point, so we can't use this one, so we're gonna use this 2-point point E, and then also point M, and also point M. Right, so therefore let's go point EM with a gradient y at E minus y at M. Even if you use y1, x1 or x2, guys, it's fine as long as you substitute correctly. So y at E is 3 minus y at M 0 all over x at E minus 1, and then also minus 3. Okay, great stuff. So now this gives us an answer of -3/4. Excuse me. Oh yeah, +3 over -4. Okay, over -4. Right, so this is our gradient at ME. So therefore the reciprocal of this, the gradient of E of the line EC, of the line EC, should be equal to 4/3. Okay, so that's the gradient of the line, should be 4/3. So therefore with that we can come here and substitute into our equation any point. So in this case we're going to use point E with the gradient of EC to be able to get the equation thereof. Okay, great stuff. So y minus y at E is going to be -3 is equals to gradient 4/3 x minus into -1. Great stuff. So now with this we can simplify y. It's equals to, remove the bracket 4/3x, then it's going to be +1 here, so +1 times 4/3, just 4/3 plus 3. From this side you took 3 to the other side, therefore y is equals to 4/3x. And therefore let's see, this together the fraction will give us 13/3. So therefore this will be the equation of our tangent of EC. Great stuff. So 4.3, I hope you are following, guys. 4.3, the length of DM. Where is DM? So it's this length here. They want us to find this length of DM, but however we don't have the coordinates of D, so D lies on this equation, so we can find out excuse me, we can find out what is the coordinates of D, then we use the distance formula, right? Okay. Oh, excuse me, guys. All right, so now this is what we have, the equation of 4.3. This is the equation of EC is given by 4/3x plus 13 divided by 4. So in this case, no, divided by 3 rather, sorry about that, divided by 3. So now here we get it when it's it's x-intercept, so we get it when y is equals to 0. So when y equals to 0, what is x here in this case? X plus 13 over 3. Take the minus 13 to this side. Minus 13 over 3, it's equals to 4 over 3x. Therefore you are looking for, you multiply everything by 3. Multiply everything by 3. This and this would cancel out, 3 and 3 would cancel out. Therefore you're going to have negative 13. Negative 13 is equals to 4. Then you divide by 4. X will therefore be equals to x will therefore be equals to negative 13 divided by 4. That's our answer there. So now what we can do now, here we have got negative 13 divided by 4 as our answer. Either we can use the distance formula between M and D. We can say dm is equal to, or we can just add them together. So as you can see, 13 over 4, then from 0 to this side is 3, then from 0 to M is 3, from 0 to D it's negative 13 over 4. So you can just add them together, 13 over 4 plus 3, which gives us an answer of 25 over 4 units, right guys? So even if you use the distance formula, you should get the same answer, or you use a distance formula, okay? So even if you use a distance formula, guys, between D and M, you should get the same answer. Please let me know on the comment section if you use the distance formula, did you get the same answer or not, right? Okay, and then 4.4, they said show that P is negative, it's equals to negative 5. So P, where is P lying? P is here on this line here. All right, so now let's see how are we going to do this one. P, it's on this line. Oh, it's also on this line here of the tangent as well. So we can say what is y if x is negative. So let's come here, 4.4 y in the same line EC, the one we calculated. So that's why, guys, it's so important that when you start these questions, make sure that the questions that you have calculated are correct. You can always double check your answers, because you're gonna use these answers anyway as you carry on with the question. So now at C, x is equals to negative 7. So we're gonna substitute that here, and let's find out what is y at C. So 4 over 3 negative 7 plus 13 divided by 3. So y at C is equals to this. Right, let's see. So if you were to do this in your Casio calculator, guys, you should get negative 5, which is also equals to P. Great stuff. So I think we managed to get that one out of the way. Now let's move on to 4.5. So guys, I am Gaston Mapala, right here at Maths with Gaston, busy with mathematics with you guys. Let me know what you think. What can I do to improve the content, or if you're following, or am I moving too fast for you? Please let me know on the comment section. If you're enjoying this video, give this video a huge thumbs up. Consider subscribing if you haven't done so. Right, okay, 4.5 rather, they said calculate the coordinates of S if S, E, M, C, it's a parallelogram, and S, the X coordinate is less than 0. So if it's less than 0, it means it's here. X is negative here and here. So for this to look like a parallelogram, I'm assuming that this has to be here. Right, there you go. That should be our S coordinate is sitting right there. Okay, so now this is what it is. Okay, with that, then we know that here we've got -5. There we've got D. We know the coordinates of D is -13/4. Right, got a lot of information here. We left it in the previous diagram, but it's not train smash. Okay, so this is what we have now. So now they said we must find the coordinate. The best thing to do here, guys, is to find the midpoint here. Let me change the color so that it's easy for you guys to see what I'm talking about. The best thing to do here is to find the midpoint here, because now if we find the midpoint between these two coordinates, therefore we can work backwards and find the coordinates of S. So now we're gonna find the coordinates, the midpoint between E and C, because it's also the same the other way around. So now we're gonna come here, 4.5. Here's the midpoint. We're looking for the midpoint between EC, or CE rather, it's fine. So X at E plus X at C all over 2 should be also the same as Y at E plus Y at C over close divided by 2, and then M AC is equal to, okay, at E we're gonna have -1 there, and the minus plus into -7, just to show the substitution, guys, right, divided by 2. Therefore here you're also going to have Y at E, which is 3 minus -5. Okay, try by all means to show everything, guys, as it is, because if I take shortcuts, I know some of us, we do get lost when we take shortcuts, and most likely to make a mistake with the shortcuts thereof. Okay, so this is what you have. So here is going to give us a -6. -6 divided by that is going to give us -6 divided by 2 is the -3. Wait a minute. Okay, so -1 negative, oh, it's going to give us -8. Yeah, -8 divided by that, -4. Sorry about that, guys. -4 here, -4, and then here we're going to have a -2 divided by -1. Okay, and kind of makes sense. On this third quadrant, everything is negative, so those are our coordinates of the midpoint here, -4, then -1. So now we can continue now to come here and say, okay, no, now we have got this line, we've got coordinates of S that we don't know. We have got a midpoint here of -4 is to -1, and then we have got a point here, point M, which is at 3 is to 0. Okay, so now we can work backwards, use the midpoint backwards. So on the point S, X, okay, we're gonna have the midpoint of EC at X is equal to SX, okay, plus the X value here at M all over 2. But you already have the midpoint here, which is negative 4 is equals to s plus 3 divided by 2. So multiply by that is going to give us 8. So you're going to have sx is equals to negative 8, negative 3. Sx is equals to negative 11. Okay, great stuff. So you will do the same for y. In this case, we're going to come here and say, okay, the midpoint at y is equal to the s at y. Also, when you substitute the m1 there, it's just plus 0 all over 2. So you've already calculated the midpoint. Here it is what? Negative 1. It's equals to sy plus 0 divided by 2. Cross multiply sy is going to be negative 2. So therefore, the coordinates of s will be given by negative 11, negative 2. Great stuff. All right. So now let's move on. 4.6. 4.6 says here, if the radius of the circle centered M is increased by 7. So currently we know that the radius here is 5, and then the radius here is 5. So if we increase this radius of 5 by 7, so it means our new radius is going to be 7 plus 5, which is equal to 12. Okay. So this is the new radius, the new one. Okay. And then there's a determine whether S lies inside or outside the new circle. Support your answer with necessary calculations. All right. 4.6. There's a saying that in analytical geometry, this one, guys, is not there. Your teacher won't show you this one. It says that if you want to know if a point lies inside or outside, it says here the distance, right? So the distance that you're gonna get, I'll just show you now. If that distance is less than r, therefore the point is what? It's inside. It's inside what? The new circle. So similar thing would happen if the distance, so please take note, guys, write this one down, is greater than r, therefore it means now you are outside the circle. Great. So now let's go ahead and found the distance. Which distance are we finding? The distance between the 2 points, the point S and the point of the previous center. So we are using this original center to find out. So you must use the center to find out. So this is our point that is in question, and this is our original center, right? You get it? You use the original center. So now let's go ahead and find the distance. So the distance, guys, you guys know how to use the distance formula. I'm not gonna show the formula here, but you must write it, guys, for the sake of marks and also for you to show where you are substituting. All right, so I'm just gonna go ahead and do it. 3 minus minus is going to be positive 11 all squared. You can double check me, guys, here. 0 minus minus 2 all squared. So therefore the distance SM is going to be equal to 10 square root of 2, which is equals to 14.4. Yeah, 14.14. Right. So now if you see what is the new radius is equals to 12. So therefore the distance that we have here, which is 14, distance is greater than r. So if distance is greater than r, it means what? S, which is the point in question, lies outside. It lies what? Outside the new circle. Lies outside the new circle, right? It lies outside the new circle. All right. And that's how you would deal with a question like this one. One more question to go. Let's move on to 4.7. If you don't understand, guys, please let me know on the comment section below. I am Gastin Mapala, solely here at Maths with Gastin. Interesting question, the last question. So let's go ahead and have a look at it. Okay, great. We're back with the 4.7. Right, 4.7 here, it says, let me just put back the coordinates here. We've been working so much in the previous pages, so some of the coordinates here, they disappear as I move along. Right, so now let's look at this one. It says that if ET is drawn, so which one is it? ET is drawn. So if we draw from here to there, okay, calculate the size of angle ET. This angle here, that's the angle in question. So now they want us to calculate that angle, right? So now let's have a look. We have got here, we know that this is radius, so this side and this side, they are equal, make no mistake. And then the reason about that is that they are radiuses. Okay, so now the best thing to do in this case, when you deal with analytical geometry and they ask you for angle, always think of angles of inclination all the time, right? So now let's have a look. Do we have a radius here? Because if we were to get the radius of this line of ME, okay, 4.7, guys, make sure that you follow. This is worth 5 marks, né? Right? So I'm gonna try to be as slow as possible so that everybody can follow. But if you don't, please let me know on the comment section below. It's equal to this. We calculated it previously. If we can just go back here a little bit, gradient of ME, it's negative 3/4. There it is right there. We did calculate it, guys. So now it's negative 3/4. Okay, so also what else do we need? We also need the gradient of this line here, which is the gradient of MC, right? So now let's go ahead and gradient of MC, which is the gradient of this line. So we've got the gradient of this line and we also have the gradient of this line. So this gradient we have, this gradient we have. So if we've got that gradient, and then we can get the angles of inclination. So remember, angle of inclination is the angle that the line makes with the x-axis. So which means in this case is going to be this one. Great. And therefore, and then in this case, which is this one, is gonna be that one there. Great. So now let's see. Okay, where we go, it's equals to 1/2. That's the gradient, guys. I'm not gonna show the calculation of how to get a gradient. I'm sure you guys know that by now. All right, so this is what we are gonna get here. Okay, let me see, let me just remove the coordinates, because in this instant I don't really need them anyway. So now let's come here and say, okay, so the angle, I'm just gonna say, let's call this angle what? Yeah, let's call this angle M. Let's call this angle M. Okay, I'm gonna take it step by step here, guys. No need to rush. Let's take it easy. So it's gonna be just angle M. Let me just call it angle M for now. Okay, angle M, which is this angle here, guys. Is this angle here? I am initially mistaken because it's a negative. So if you don't include the negative, then you're gonna have to do something else, 180 minus. So in this case, just to say shift turn, remember, negative 3/4 gives us how much? 36 point, I'm getting 36.87, right? So this angle here, guys, it's what? 36.67. Okay, I hope you guys are following. It's 36.67. So now we're gonna have to come here and find 36.87. So now let's go ahead and find the gradient of this one, 26, the one of 20. Let me see. Excuse me, guys, just double checking my math here. The gradient, this angle here, yes, let me find this one here. Okay, because I'm using the gradient of this line. Remember, it is the angle that the line makes with an x-axis. So the first line is making this angle, the second line is making this angle here. Let's go ahead and use a different color for the sake of understanding. So with this one, we're calculating this one here. Okay, so it's just gonna be the red M now. Okay, so it's gonna be the one of MC is equals to tan shift 1 over 2. So this would be our angle now. Is going to be how much? It's giving us 26.570, right? So I've got this one now, 26.570. Great. So now what does this mean? This means now you have got these two angles. It means now this whole angle here, the whole angle here, right? Let's do this. It means now this whole angle here, hope you guys can see the yellow. This whole angle here is the sum of the two angles. So now this is what we can do. So therefore the total M, angle of the total M, is equal to 36.87 plus 26.57, which gives us an angle of 63.43, which is this angle here. Great. So now with that, so now because now here this is what we have. Excuse me guys, this is what we have, because now here we have got these two sides are equal because of the radius. So these two sides are equal. Remember what we said initially. So this angle here is equal to this angle here, right? So now it means we can say we have got a triangle like this one. If you remember Euclidean geometry, guys, we've got an E there, we've got our M here, we've got a T there. We're looking for T. We already know this gradient. These two, they are equal. So now because of the radius, so we can just add the two together and then find the other one. So the sum of angles in a triangle is equals to 180. So this is what we can do. So it means T, which is the same as E, plus M must give us 180. Remember E and T, they are equal because of the radius. So you can come here and say these two, they are equal. The reason would be radii. So even if you don't write this one, guys, but I think it's worth it, we're writing so that when you come here, you can say T plus T is plus 63.43. It's equals to 180. Therefore here you're going to have 2T is equal to 180 minus 63.4 divided by 2. So therefore our T will have to be equal to 58.28 degrees. Yeah, and that's how you would deal with a question like this one. It's just one of those, guys. It's just one of those, I know, but if you had followed, I'm sure you fully understand what I did there. If you're not sure, please let me know so we can do more questions like this one. I am Gaston Mapala. Let me see you on the next one where we'll be doing question 5.